everyone, myself Tejashree. I am studying Electronics Communication Engineering in SRIT College, Anantapur. My roll number is 23401A04B6. Today I am going to explain about the topic numerical problem on state space analysis from the subject control systems, and the subject code is 233E404. Numerical problem on state space analysis. Firstly, we have to know about the state space analysis introduction. State space analysis is an powerful and modern approach for the design and analysis of control systems. The conventional or old methods for the design and analysis of control systems is based on transfer function method. The transfer function method for design and analysis had many drawbacks, such as transfer function is defined under zero initial conditions applicable to LTI systems. SISO systems does not provide the information regarding internal state of the system. Initial conditions can be incorporated in the system design. State equations are highly compatible for simulation on analog or digital computers. Firstly, we have to know the model of the state space. Here you can see the block diagram, system described by state variables and input vector and output vector. Let us consider a multiple input and multiple output system is having, or is inputs u1 of t, u2 of t, or etc. ur of t. M number of outputs are y1 of t, y2 of t, and so on, ym of t. N is the number of state variables, x1 of t, x2 of t, and so on, xn of t. Firstly, state the equation. Xi of t is equals to ai xi x1 of t and plus ai2 x2 of t plus and so on ain xn of t plus bi i1 u1 of t plus bi2 u2 of t plus and so on bim of t. State the equation in the matrix form. Derivative of x1, x2 and so on xn is equals to a11, a12 and so on a power n, and it is in the form of x dot is equals to ax plus bu. Output equation. Yj of t is equals to cj1 of x1 of t plus cj2 x2 of t plus and so on cjn xn of t plus dj1 u1 of t plus dj2 u2 of t plus and so on djm of t. And output equations write in the matrix form, y1 y2 y2 and so on ym, and c11 c12 and so on cn. And finally the output equation is y is equals to cx plus du in form. Here we can see the one problem on state space analysis. Obtain the state model of the system whose transfer function is given by y of s by u of s is equals to 24 by s cubed plus 9s square plus 26s plus 24. Here the solution is firstly given y of s by u of s is equals to 24 by s cubed plus 9s square plus 26s plus 24. By the cross multiplication, s cubed plus 9s square plus 26s plus 24 into y of s is equals to 24 into u of s. S cubed into y of s plus 9s square into y of s plus 26s into y of s plus 24 into y of s is equals to 24 u of s. Taking inverse Laplace transform on both sides. D cubed, derivative of y of t plus 9 into d square y by dt square of t plus 26 into d by dt into y of t plus 24 into y of t is equals to 24 into u of t. Here we can write that d cubed by dt cubed in the y triple dots. So y triple dot of t plus 9 y double dot of t plus 26 y dot of t plus 24 y of t is equals to 24 u of t. Choosing the state variables as successive derivatives. x1 of t is equals to y of t, x2 of t is equals to y dot of t, x3 of t is equals to y double dot of t, x1 of t is equals to y of t, x1 dot of t is equals to x2 of t, that is equals to y dot of t is the equation 1. x2 dot of t is equals to x3 of t is equals to y double dot of t, that is equation 2. x3 dot of t is equals to y triple dot of t. Here the equation is substituting 1 and 2 in the first equation. Then y triple dot of t plus y double dot of t plus 26 y dot of t plus 24 y of t is equals to 24 u of t becomes x3 dot of t plus 9 x3 of t plus 26 x2 of t plus 24 x1 of t is equals to 24 u of t. Here x3 of t keeping its left side and remaining all terms turn to the 24 u of t side. Then x3 dot of t is equals to minus 24 x1 of t minus 26 x2 of t minus 9 x3 of t plus 24 u of t. It becomes equation number 3. Putting equations 1, 2 and 3 in matrix form. On the left side, x1, x2, x1 dot of, x2 dot of, x3 dot of is equals to, here first two terms are fixed constants in state space analysis. So here you can see the equation 1 in x1 place. Here x1 of t is equals to x2 of t. So where x2 in that place we kept as 1, remaining places 0, and x2 dot, here x2 dot of t from the equation 2 x3 of t. So in the place of x3 of t we kept 1 and the remaining places as 0, and x3 dot from the equation 3 in x1 of t place minus 24 and x2 of t place minus 26 and x3 of t place minus 9 into x1, x2, x3 plus 0, 0, 24 from the equations 1, 2 and the 3. The output expression is y of t is equals to x1 of t, that is equals to 1, 0, 0 into x1, x2, x3. That is the final answer. Thank you.